Okay, so we're going to try the same thing. This time I'm finding f of x plus h, and I'm putting in a number. It's just going to be the x plus h, and the function is the square root of x plus 1. Okay, so first step, I need to find f of x plus h. Right, what is f of x plus h? Correct. Okay, and the f of x we've already got, right? There's nothing to do there. So this is going to be the limit as h approaches 0 of the square root of x plus h plus 1 minus the square root of x plus 1 divided by h. Now, you could try into the direct substitution, but when you're doing a difference quotient, direct substitution will always give you the indeterminate form. It will always be 0 over 0. What technique do we have to simplify this? The rationalizing is what they call it, the rationalizing technique. So what do I do here to simplify? Multiply it by the conjugate of this, right? So I need to multiply by the square root of x plus h plus 1 plus the square root of x plus 1. And if I do that in the numerator, then I'm going to have to do that in the denominator. Okay, in the numerator, again, we have to FOIL that out, but in the end, the middle terms are going to cancel, so we could skip that step. What do I get when I multiply the first terms? I'm going to get x plus h plus 1. Okay, then I'm going to subtract. It'll be minus the square root of x plus 1 times the square root of x plus 1, which will be minus x plus 1. And either put it in parentheses to make clear you're subtracting that whole thing, or make sure you do minus x minus 1, or else it's not going to work. Right? And in the denominator, I still got h times the square root of x plus h plus 1 plus the square root of x plus 1. Okay, how does the numerator simplify? We've got this x minus x cancel. Right, and the 1 minus 1 cancel. So all that's left is the h. And that's always what happens with difference quotients. If you remember, even when we did them in the first chapter, we said, when you do this f of x plus h minus f of x over h, every term should cancel that doesn't have an h in it. Right? Everything left should have an h in it. So here we go. This will be h over h times the square root of x plus h plus 1 plus the square root of x plus 1. Well, we're about to do that. Right? So now, because there's an h here and an h here, they cancel. I'll go over here just to give it space. So we're taking the limit as h approaches 0 of 1 over the square root of x plus h plus 1 plus the square root of x plus 1. Now, try the direct substitution now. I mean, does it lead to a 0 over 0? No, I mean, clearly doesn't do that because you have a 1 in the numerator, so it can't be a 0 in the numerator. what's going to happen to the denominator if I let h equal 0? It's going to be the square root of x plus 1, right? By plugging in a 0 here, you're just going to get the square root of x plus 1 plus the square root of x plus 1. It's 2 times the square root of x plus 1. So by plugging in the 0 there, we get 1 over 2 times the square root of x plus 1. And that is, it's, you know, in this case, it's an equation. It's not just a fixed number. We haven't set it, which x value we want to know the slope. Yeah. Yes. And just for grins, just to show you that in this function right here, you could actually use that technique I was showing you with calculus, how they do the derivative. You would do it like this. If I rewrite the f of x as x plus 1 to the 1/2, right, use the rational exponent, and then use the same property, which is bring this to the front and then subtract 1 from the exponent. It's 1/2 minus 1. Negative 1/2, right? And how do you resolve the negative exponent? You flip it to the other side of the fraction, right? So now we've got 1 over 2 times x plus 1 to the positive 1/2. But that's that. It's the same thing. So you can use the same pretty simple technique for finding derivatives, even when it's a radical. Just write it as a rational exponent, and you do the same thing.